Okay, these are some equipotentials. So this will be 50 volt, 40 volt, 30 volt, 20 volt. Can we say anything about the field strength at various points? The separation this is uniform, so this will be 2 centimeter. The separation here 4 centimeter. The separation here is 3 centimeter. Now, can we say first about the electric field strength? Now, what are these lines? They are the equipotential surfaces. If I give equipotential surfaces, can we just roughly say that what is the direction of electric field, and can we say about how much of field strength at a given point? How the electric field strength vector should be directed? It should be always directed perpendicular to equipotential surfaces. So here I have to draw, this may not be exact, just to make you understand I'm bringing. So it will be here. You have to see that everywhere the lines of force should be perpendicular to equipotential. In that way, it has to be drawn. There's a maybe rough diagram. This will be the lines of force. No, at points P1, P2. Okay, there's a point P1, P2, and P3. I'm asking you to estimate the average electric field. So we know what is electric field. E1 should be equal to delta V by delta X. What is the delta V potential difference? 50 minus 40 by what is the separation? 2 centimeter. So how much it will be? 10, 5, 0.05 volt per meter. Is it okay? Because it is there in centimeter, no? Similarly, what about average electric field at point 2? Point 2 will be 40 minus 30 by separation. What is the separation? 4 centimeter. So this will become 40 minus 30 by 4 centimeter. 10 by 4, 10 by 4, 5 by 2, 2.5. So 0.025 volt per meter. Then electric field strength at point P3. 30 minus 20 by 3 centimeter. 10 by 3, 3.3 or 0.033 volt per meter. Look at the field strength. Like this average, this is not exact. Because again, here the field will be variable. Average fields at 0.1923, I'm predicting here.
Sir, centimeter is in the denominator, no, sir. So it will be multiplied by 100.
Centimeter, huh? Correct, no? Multiply by 100, no? 50 will become, sir. Yeah, 500, 500 it will be. No, 50 it will be. 500, 500 it will become. This will be 250. 3.33, 33. This will be 10 by 4, no? 2.5. 2.5 into 10. 2.5 into 10 will be 250. This will be 10 by 3, 3.33. Check once. Some. So if they give some equipotential surfaces like this, as we can roughly estimate. What is the method here? The electric field strength vectors should be such that it should be perpendicular to equipotential surface. That's the one basic idea. Now, instead of this, if the equipotential surfaces are, I have a space here, I'll draw it here. Okay, these are the equipotential surfaces where the potentials are given 50 volt, 40 volt, 30 volt, 20 volt, 10 volt. Okay, zero potential, let me not show it. And these distances are yeah. So this will be 1, 2, 3, 4, 5. X is in centimeter. Okay, what I want is like I want the electric field strength vector. Electric field strength vector. These are the equipotential planes. What is the basic idea? Like E equal to delta V by delta X. That's all. No. So what is the condition for delta X? Just I'll close the window. No. What is the condition for delta X? How delta X should be measured? I'll have water. Let me have water also. Can you hear me? Shall I continue? Okay, some again power gone. No. What is delta X? Anybody? How I should measure delta X? This is very fundamental question. Delta X should be measured normal to along E bar. That's the basic idea, no? Or it should be measured normal to the equipotential surfaces. So very simple. Delta X is measured along E bar. I'll write it. Measured along E bar. Okay, now I know this distance. What is this? This is the 1 centimeter. And we know how E bar should be perpendicular to the equipotential surface. So therefore, so shall we bring the idea like this? Then what is delta X here? So will you take delta X this one or this one? This should be the delta X or delta R. I'll write it because X I think will confuse. So what is delta R? Delta R shall I write here? This one. First of all, how E bar will be? This is a primary question we have to ask also. The E bar will be directed in this way. Normal to the equipotential surface. So therefore, this cannot be delta R. In fact, this is delta R. The equipotential surfaces, let them make angle 30 degrees. So we know this angle 30 degrees. Then can we calculate now? We know delta X, this is so cos sine 30. Yeah, sine 30 will be delta R by delta X. So delta R is equal to delta X sine 30 degrees. Delta X is 1 centimeter. So this will become 1 by 2. let's get into the calculation part. What is the calculation says? We know potential difference. What is the E bar? E bar is magnitude is needed, no? Delta V, 50 minus 40 by delta. Delta is how much? 0.5. So this is in centimeter. You have to convert into meters. So how much you get? 10 by 0.5, 100 by 5, 20, 2000 volt per meter. The magnitude. I want the direction. What is this angle? 60 degrees it will be. So what is the electric field vector will be? E cos 60 degree I cap minus E sin 60 degree J cap. So what is the value of E? 2000. Cos 60 will be 1 by 2 I cap 2000 root 3 J cap. So what is the resultant field vector will be? 1000 I cap minus 1000 root 3 J cap volt per meter. If they give the potential equipotential surfaces, can you find out E bar S? There are two types of potential surface I brought. One which is where non-uniform electric field. Here, what is the field? Field will be non-uniform. What about this red color arrows? Lines of force. Complete description are there in front of you. Just do make observation. It's a very small idea. Like some books, they are going to some very high level, may not be needed for us, I feel. It's a pure mathematical one. So unnecessary books, they're given plenty of numericals, but just we need some basic idea. If you know equipotential surface, can you find out field S? If you know field, all this, what is very important? If I have electric field, see, I'm once again, I have electric field vector and these points. What is the potential difference in 1 and 2? V12 should be equal to E into D because the field is uniform. This is what needed for us. Or 1 by from 1 to 2. This is what finally we have to conclude this much in this chapter. Okay, now let's explore some the different types of numericals.